All right, in this example, we're given the graph of f of x, and we're asked to graph g of x and h of x, where those two functions are defined in terms of f of x. Okay, but this time we're adding something to the input instead of adding something to the output, right? Like we did in example 2. So let's think about what's happening here. Now I can find, for example, let's just take this point right here. This is the point, oops. This is the point -1, comma 2, right? So this is saying that f of -1 is 2, right? I could write that down. F of -1 equals 2, right? That's representing that point. So if we're given that point, how can we find g of x? What happens to that point in g of x? Sometimes I like to look at it as a graph. So the input to the function now is x plus 2, and I can find f of x plus 2. Oops, plus 2. All right. So I know when the input to f of x is -1, I get an output of 2, right? So what value of x will give me x plus 2 equals -1, all right? Because I know the input. Now the input to f of x is x plus 2, right? And I want the input to be -2, so what does x have to be? All right, so x would have to be what? It would have to be a -3. If I add 2 to -3, I get -1. And so what's happening is that now if x is equal to -3, then I get f of -1, which I know is 2. Okay, so now I can plot the point. So this is equal to g of x, right? So g of x is this. So now I can plot one of the points on g of x. So let me change colors here. And let's, well, actually, no, I'm just going to do this in green for now, right? So now I want to plot the point -3, comma 2, right? So you can see that point's just shifted to the left by 2. All right, so it's kind of counterintuitive. We added 2 to x and it shifted it to the left, which is in the negative direction, right? But it makes sense if you kind of just think it through. Take it slow, think it through. We want the input to the function to be -1 because we know that point, and so then we know that the output of f of x is 2. And x equals -3 is what gives us x plus 2 equals -1. All right, so we can do that for other points too. You know, everything is just going to get shifted to the left by 3 though. So I can take the point 1, comma 2, right? That's another point on the graph here, right? That's on the graph of f of x. So what happens to that point, we want the input to the function, which is x plus 2 now. We want that to equal 1. So what value of x gives us x plus 2 equals 1, right? So it's just going to be a -1, right? -1 plus 2 gives us 1. And so now I know that the point -1, comma 2, which actually I have it, it actually overlaps here with that other point. All right, so everything's just going to get shifted over by 2. So actually I'm going to erase this point, and let's just shift these points over by 2. So for example, this one is just going to get shifted to the left by 2. I'm going to erase this and get it out of the way. Everything, so like this point down here is still going to get shifted over by 2. So it's going to be somewhere about there, right? And then this point up here, right, gets shifted over by 2, so it's somewhere about there, right? So you can see if I connect those points, our graph of g of x is going to look something like, well, you kind of get the idea, kind of up and down. And then, okay, so this point gets shifted over by, we already got that point. This gets shifted over by 2, so we're going to end up here, right? This point gets shifted over by 2, right? and it comes back up, and then this one gets shifted over by 2, so it's going to go through this point as well. A lot of points that are overlapping, but you get the idea. All right, so okay, so this green wiggly curve is what g of x would look like. So this is g of x. All right, now let's try h of x. We're going to do a similar thing, right? The input to the function now is x minus 1, okay? And the output is f of x minus 1. Okay, so I can take a point. Like, for example, I still know that when the input to the function is -1, I get 2, right? And now what value of x makes x minus 1 equal to -1? Well, that's just going to be 0, right? So x has to be 0 in order for x minus 1 to be -1, which gives us an output of 2. Okay, so let's graph that point. 0, -1. Oh, sorry, 0, 2. Right, it's going to be here. All right, so this point got shifted over by 1 now, but it got shifted to the right. Okay, so again, it seems a little counterintuitive. When we subtract 1, it shifts it to the right, which is in the positive direction. Okay, that's just the way changes to the input work. They're kind of counterintuitive. So we can just take all of these points and shift them over by 1, right? I'm just going to take each point and shift it over by 1. Take this point and shift it over by 1. So actually, I just want to put okay, I'm going to take this point down here and shift it over by 1, and take this point and shift it over by 1. And then I'm just going to connect those dots, okay? So I'm going to end up with something that comes down, and then comes up and down, and then like this, and then back up, okay? All right, so this red graph is the graph of h of x. Oops. H of x. All right, we just took every point on f of x and shifted it to the right by 1. Okay, and so you can see that the when we make changes to the input to the function, it shifts it right and left. Okay, so let's summarize what we just learned. We saw in these last 2 examples, we saw horizontal shifts. And so if we take a constant h, a positive constant h, and subtract from x, it actually shifts the graph to the right by h units. Okay, and if we take a positive constant h and add it to x, it actually shifts it to the left. A little counterintuitive, but it just, if you take a constant off of the input, right? If you subtract a constant from the input, it's going to take more input in order to get the same amount of output. All right, so that's kind of the issue here. So when you subtract h, you're going to require h more of the input in order to get the same output. All right, so I'll meet you in the next video.